going to give everyone a couple more minutes to filter in. We'll get started. When we go ahead and get started, this is a presentation that builds off of the previous one, which Steve gave. The previous talk, we talked about how to version control your database and share your changes within your environments with other developers. This presentation is more about automating a lot of those processes in terms of deploying things to your development environment, deploying things to your QA environment, deploying staging, production, whatever. And we do that with a bunch of continuous integration tools that are normally associated with things like compiled code, but we are applying that to database development. Real quick, the company I work for is called Praxis Fusion. We're based in San Francisco. We are hiring, so we're C#, .NET, SQL Server Shop. Primarily, we only have spots in San Francisco, Palo Alto, and we're opening up a new office in Seattle. But we're open to people working remotely. So if you're in the market, please come talk to me after this talk. About myself, I'm a C# .NET developer. I'm not a DBA, I'm not a SQL developer. I mean, I can write, and I have written quite a few stored procedures and all that. So databases are not my main thing. This is just something that I felt was a problem in our environment, and we will go over some of the problems that we had, some of the solutions. If you were at the previous talk, Steve really touched upon them with regards to developers just handling dozens and dozens of scripts for every release. And as you get bigger, that just becomes unmanageable. So real quick about Praxis Fusion, like I said, we are a C# shop. This is in San Francisco, across the street from the Java convention. We have a C# is better sign in our window overlooking it. I thought that was pretty cool. And why am I here? I think this is basically a picture of me after we did our first deployment to production in a very well-rehearsed fashion. There wasn't a point where performance was bad because we forgot to add an index. There wasn't a point where The store procedure was not working because we forgot to update a column. We just deployed it for the first time, and this is going from no source control at all to having a generated script that we used against our production database, and that happened within the scope of 1 month. And so what is this talk? Hopefully you were at Steve's talk earlier, where he just talked about source control and version control in your database. And this takes it to another step where we're actually verifying that the build is okay. We do automate the running of those unit tests, and we also provide a way to deploy these changes to your integration environments, your QA environments, etc. Some prerequisites. I know Steve asked earlier, like, who is using source control, both for compiled code, for application code, and also for databases, and it looked like quite a few of you already were, which is great. The second piece of that is how many of you are using some kind of continuous integration server, whether that's TeamCity or Team Foundation, TFS, Jenkins. Good? So it's super simple to set up. Jenkins is free, and I will be using Jenkins for this demo. The remote desktop, or the Azure server that I'm using, it didn't exist on Saturday, and on Sunday I just spent half a day setting everything up. So, I mean, it's super simple to set up. It takes some getting used to, and if you're familiar with other continuous integration products, there's some analogous way to configure a job as there is in Jenkins. So whether that's running some pre-build script or a post-build script that we're archiving your artifacts, etc. And the last thing you need to know is some kind of scripting language. For this demonstration, I'm going to be using MS Build, but you can use PowerShell or Ant or whatever you want. And this is a list of some of the software I'm going to be using. I'm actually using SQL Server 2008, Sql Source Control, which Steve showed earlier, and behind the scenes, I'm going to be using SQL Compare and SQL Data Compare. We won't go too much into that, except just looking at what is generated from the output from that. Also, a big piece is Jenkins, which is open source and free. And if you're not using continuous integration, I highly recommend just throwing it up on some box and experimenting with it. And there's a list of plugins that are associated with that, and also the scripting tool MS Build. So I'm going to go over some of this pretty quickly because it was covered in the last talk, and I just don't want to dwell too much on it. SQL Source Control is basically, if you've used a product like Tortoise SVN or Tortoise Git, it's a similar tool that is part of SQL Server Management Studio. So in Tortoise SVN or Tortoise Git, if you make a change to a file that hasn't been committed, it'll show up with a red icon saying, oh, you need to commit this change to source control. If you make a change in your database, if you alter a table or if you alter a stored procedure or create a new stored procedure, that object in SSMS will show up with a blue icon next to it showing that you need to commit it. And basically it defines the schema and also lookup tables within your database in such a way that other Redgate tools can deploy it in a very optimal fashion. So it knows whether you need to create a table or alter an existing one. And for the most part, it'll figure out if you rename columns or if you change a column from bar chart 100 to bar chart 80, and it does its best to minimize the impact on your database. So obviously, if you go from 200 to 100, there may be some truncation involved, and it'll warn you, things like that. So if you guys remember back to your SAT analogy questions, so SQL Source, in my mind, SQL Source Control is to SSMS as Tortoise SVN is to Windows Explorer. It's just a shell extension or a plugin that makes committing to a source control repository very easy. And so, yeah, this presentation is pretty demo heavy, so it's really important that you understand what my environment is. And so, one thing that I'm going to be doing is I put everything in GitHub, which, in case you don't know, is just a publicly hosted source control repository. And everything is downloadable. You can, even this presentation is part of that repository. The database structure and even the configuration of my continuous integration server is up there. So you should be able to reproduce this demo locally. So that's GitHub. On my machine, I'm running SQL 2008 SSMS, and I am also running Sql Source Control, so I can check in those changes. And my local machine is playing the role of any one of the developers in your environment. And then the last piece of this demo is I have a Windows Azure VM, which is, I could have split it up into different servers, but it's acting as both the continuous integration server and also as the database, various database servers. So it's hosting a development or integration environment, copy of the database, a QA environment, production, and it's also performing the duties of the continuous integration server. So what does it look like committing changes to source control? Steve gave a little demo of that earlier. I'm just going to go over it real quick. So you're going to have to ignore all my actual real work databases that I have here in SSMS. We're going to be working with this database here called RGDemo. And there's a backup copy of this database on the GitHub repository, and I'll show a link to that GitHub repository later on today. You can just back up, or just take that backup, restore it locally on your machine, and it'll work fine. Link it to source control using the same technique that Steve showed earlier. So I'm going to open up a store procedure. So the store procedure just prints out a statement, hello SQL, and the city users and has to be there. And I'm going to put a very important message here. So it's also important to know that I just moved back to LA from San Francisco, so I'm very glad to be back. Yeah, I lived there for 3 years while they won 2 World Series. Not happy about that. So I made that commit, or I made that change, like Steve showed earlier. You can take a diff of the change. You can see what's changed, and because I'm a good developer, I'm going to put a commit comment, and I check that in. Now, one important thing that is different here than probably what you would normally do at your work environment, there's an additional step you have to take when you're using Git. And I could have used Subversion, but I really wanted to make all of this source code available to you guys. So there's an additional step that you have to take here that you normally wouldn't take, just because Sql Source Control doesn't yet integrate with GitHub in a super clean fashion. So I have to go back to my repository. It's been committed here, and if you were to look, if I show log, so you can see that my commit is here, but I still have to push it back up to GitHub, and do that with the Git Push. And so if you use SVN, you wouldn't be taking this step here. And I'm going to try not to type my password in the username box. So if you see me type my password, just yell at the screen. So now that's been committed. And it's been pushed, sorry. And like Steve had in his demo, I have other copies of the same database locally, and if I were to first pull down those changes for, let's say, Aronson, and again, you wouldn't have to do this if you were using SVN. And then if I were to go to Aronson's copy of the database, you can see that that changes the weighting and I just apply it locally. So that's basically a real quick version of what Steve went over in the last demo. So then, how does continuous integration fit in? So not only do people have to commit changes, but you need a way to validate that nothing broke, and that's where continuous integration comes in. As soon as you make a commit and it's accessible by everyone, your continuous integration server is sitting there waiting for the change, and it detects a change, it pulls down everything, and it tries its hardest to make sure that nothing breaks. So one thing that I have my continuous integration server do is it creates a blank database from scratch. It creates all the tables, it creates all the views, creates all the stored procedures, it adds all of the lookup table data, and then once it's built successfully, it just deletes, it drops that database. And that's one way that you can validate that nothing broke. So let's say you rename a column that was used in a stored procedure, the creation of that stored procedure is going to fail. Or if you drop a column that's used in a view, then that view is going to break. And that step of the process just ensures that no developers are causing problems. It can also run unit tests, which is something also that Steve touched upon. And then it also archives that definition of the database so that you can deploy it to different environments. And you might want to have one version in development or integration. You might want to have a different version of that database in QA because the developers haven't finished integrating yet. And then lastly, it emails people who broke the build. And you never want to be that guy, especially when you commit something and then you leave on Friday and go on a 5-day vacation. And people start yelling at you. So, time for the next demo. So, yeah, I'm really proud of this image I made. I even looked up boron, and I put the atomic weight and the atomic number and the electron configuration numbers in there. Anyway. So, demo time. Breaking the build. It's a great show, by the way, if you haven't watched it. Highly recommend. So here I'm going to do just what I said you should not do, is just willy-nilly deciding to rename columns. Like, oh, I like unit price amounts. That sounds more intuitive to me. So I'm going to make that change, and it shows up in the change list. And my comment is, I like this name better. So I've made that change, and we get to push that. I know I'm going to at least one time type my password in this clear text box, so I might have to destroy that videotape.
welcome to that process.